Hi guys, welcome back to the Astroimaging channel. Tonight's session by Ken Sturrock on scripting in the TheSkyX, and I believe it's going to be an interesting session. He presented it to me as for people who have Macs. They need to do some odd things and they don't want to buy a PC necessarily. But when I was discussing it with him, it actually seems to be a little bit broader than that. So I think it's going to be a really interesting presentation. But first, as always, we're going to go to our image of the week, which is by Rob Simmons, and I'm going to try and pull this up quickly. It always seems to take me so long, but here we go. Oh, I had this thing opened up. Don't tell me it disappeared on me. It must have disappeared on me. Give me 1 second. Oh, what did I do there? I am sorry. Let's see. And this image by Rob Simmons is Pelican Nebula, starless. And you know, we like starless images here. It really shows off the structure of the nebula well. And especially with narrowband, you can do a lot of creative things, bringing other types of other colored stars back in. And very nice image here. And obviously the big Haro objects in the Pelican, just a great target, especially this framing. And we did not give Rob much advance notice, so if he does join us in the room, he's welcome to make some comments. And Rob, I'll make sure you get an invite to the room just in case you didn't get it, but I'll send out another one. But for now, I'm going to jump right back over to the presentation, and I'm going to take back the mic and hand the presentation over to Ken. I know Ken is in the room.
Okay, am I there?
We see you and we hear you, yes.
All right, well great, thanks. Yeah, I approached Adam with this idea, and I thought it would start off as being something kind of small, and it just kept morphing and it got bigger. This is kind of a risky presentation because those of you guys that know about programming might be bored, and those of you that don't know anything about programming will maybe be bored. So I'm going to try to step through it as quickly as I can. And let me see if I can get this to work here, Adam, and do the screen share. Is it working there?
Looks like you got it, yep.
All right. Does that work, Adam?
Yes, we see your presentation.
Okay. Yeah, so a little bit about me. I'm actually an emergency manager, and I work for the U.S. Department of Health and Human Services. And except for a little stint in the Foreign Service, I've always pretty much worked in public health and emergency management. I've been a kind of a serious amateur astronomer, you know, in that I owned a telescope since about 2000. And I've been imaging off and on for the last 12 years. Mostly it's just something I do for my own amusement and to try to see if I can get myself to do a little bit better each time. So that's a little bit about me. What I'm using right now for my astrophotography setup is a pretty simple 4-inch refractor. It's a StellarView SVQ, which is one of the Asian quad telescopes. So it's basically a triplet. And then it's got a single element in the back as a field flattener. And I've got a QSI and an EM200 mount. And then for software, I use 2 programs. I use TheSkyX for OSX, and I use PixInsight for OSX. And one of the things about running on the Macintosh is that since you don't have quite the selection of software, it makes it easier to run on fewer programs. I know that's a goal, but with the Mac for some, but with the Macintosh, it's pretty easy. I started off on Windows, and I'm not afraid of Windows. I use Windows regularly, but I kind of prefer to do my own stuff on OSX. And again, I usually image from my backyard, which is about 2.5 miles from downtown Denver. So there's a lot of light pollution goodness there. Now, the EM200 is not an exotic mount. It's been around for quite a while, but it doesn't get much love anymore. And I think one reason is because they're relatively expensive, new, partly because you've got currency fluctuations, And then the other reason is just because they're expensive. On top of that, they're low tech from an electronic standpoint, but they have a lot of high mechanical quality. So they actually have functional and working setting circles. You can actually use those to find things. So that's very old school. And then they have a polar alignment scope. I don't know if you can see. Can you see the cursor here, Adam?
We can see, it's cut off by Eric's head for me, but I think...
Oh, okay. Well, I don't know if you can see the bottom view here, but basically that's the polar alignment scope. And the Takahashi polar alignment scope works by you adjust a scale on the side until it corresponds to your longitude, and then you rotate it until a bubble level is level, and then you look through the scope and you can rotate a ring. And inside the scope you have two markings, two circles around the outside, one for date and one for time. And you rotate them until the time and the date marks for the current moment align with each other. And then you have a long rectangular box which is marked for years, and you put Polaris in the right spot. Now it literally took me longer to explain how to use it than it does to use it. And it's really a pleasant mount to use. And for my short focal length instruments, that's all I do. I don't do anything else electronic to get it to work. The mount itself is very primitive electronically. There's no PEC, there's no stops. So if you set it to image or to track, it will happily track into itself. There's nothing to stop it. It has a very simple hand controller which lets you slew with some arrow keys. But to do go-tos, you have to have an external computer. And like Adam's AP that he talked about last week, once you polar align, you do a one-star go-to alignment, and it assumes that you're done. So the pointing model is very simple. But that's okay, because if you're using other software, like, say, SkyX, it can work as the brains. So the Takahashi is fully T-point compatible. If you really want to build a complicated, sophisticated pointing model, I don't ever do that myself. And it's compatible with closed-loop slew, which is the baked-in slewing system in SkyX that's plate solve enabled. And I use that a whole lot, and we're going to talk about that later. So a little bit about the SkyX Professional. It is a full-featured astronomy package. So it has planetarium, and it controls cameras, and it's got an elaborate database with a lot of properties for objects. It does operate differently from some other programs. So folks will get annoyed with SkyX, in part because it's big and complicated, and in part because it's just different. Some things it does, I think, better. Some things it probably does worse, but it's just different. I would also say that if you've been on cloudy nights, you might step away with the opinion that SkyX is just this annoying program that you have to use in order to control your Paramount. But I would say that that's the other way around. I would say that the Paramount is actually the shiny hardware extension of the SkyX Professional. So a little bit about the program itself. When you're working with SkyX, you're dealing with something that's both very old and very new. So it originally came out for MS-DOS. This was the original version, the Sky, in 1983. And it was a planetarium program. And then they could control mounts eventually. Windows version came out in 92. CCD Soft was the BISC product that would run cameras and do guiding. And then the first Paramount came out in 96. And then SkyX itself came out in 2010, but the camera add-on didn't come on until 2012. So it's kind of an evolving product. In addition to different versions over time, there's different versions for sale. And this gets complicated too. So, for instance, First Light Edition is basically a throwdown. It's given away with different mounts as a beginner's planetarium program. And it's quite limited. The student version is actually a very nice planetarium program. Sirius adds telescope control and observing lists and things like that, more sophisticated lists and databases. Now, when you get to professional, things get more interesting. because this is where you start getting into the optional and added cost add-ons. So for instance, the camera add-on introduces imaging, guiding, focusing, plate solving. T-Point is another add-on. Scripting is something that's built in. It's not an add-on. And then things like weather stations and domes are additional add-ons. And then there's also an iOS version, which is really a planetarium program, but it serves as remote control for SkyX Professional running on a real computer. No offense to tablet users. So this is a typical imaging layout for SkyX Professional for me. And I'm simple. I have my chart set up to be looking like a paper chart. It's meant for clarity. All of my buttons have words on them. I don't, for instance, have cryptic icons up here that I have to figure out. The controls for the camera and so on take up a lot of the screen. You could, if you look at the way different users have it set up, everyone sets it up differently because it's very flexible. There's a Windows version and a Macintosh version, and they pretty much operate the same way, but there are some infrastructure differences. So Windows supports ASCOM, which requires .NET, so that's a Windows thing. That means that on OS X you have fewer devices that will work. So you have good support from a lot of companies. For instance, QSI and SBIG and FLI all have native drivers. Attic now does too. But if you've got a device that relies solely on ASCOM or relies, say, on the Windows video system, if it's a video camera, then you're not going to be able to use that. Another difference is that if you wish to have your Paramount controlled by another program, that requires an ASCOM setup, and of course you can't do that in SkyX. SkyX on OS X. Windows also supports a communication and remote procedure call interface, which is kind of a legacy system. This is how Sky 6 and CCDsoft were programmed, and OS X doesn't support that. And then you'll also notice that updates for Windows come out more regularly. And that's not really bias against the Macintosh so much as it's just that there's a lot more going on in the Windows environment and a lot more devices and a lot more users to find problems. And so these updates and bug fixes come out much more regularly on Windows. Any questions so far, Adam?
There haven't been yet. Sorry.
Have not been? Okay. Now, scripting for SkyX is very primitive. If you are accustomed to the idea that you want to tell your rig, hey, I want you at midnight to point to M57 and take 14 images, and then I want you to go do something else, and then I want you to park, you don't have that kind of capability native to SkyX. The scripting capability is basically like issuing commands, but you're doing it with a program instead of a graphical user interface. Traditionally, since earlier versions of the Sky on Windows, there have been third-party applications, things like, say, CCD Commander, that will give you a nice front end for your automation. Bisq had a product called Orchestrate as well. And so this lets you do kind of high-end scripting. Now, because of the history and the RPC modules and all that, most of these, actually all of these programs were written for Windows. So if you're running OS X, there is no third-party program that will let you automate your imaging system. But both OS X and Windows support JavaScript, even though Windows supports the other system that lets you write programs, say, in Visual Basic. But they both have JavaScript built into them. So some reasons why you might be interested in scripting are some of these. I know somebody, for instance, that has written an elaborate set of scripts that reads through the SkyX databases and finds eclipsing binaries that are in good positions for the night, and then he will vet and choose them, and then another set of scripts will go off and image them for him. diagram. I know someone that's doing supernova searches. You can also try to do some pretty picture automation, but you can also write very simple scripts just to do grunt work for you, like building up libraries of darks and flats, or you can do pre-imaging work, so you can do alignments, or you can have the script set all your defaults for you to make sure that everything's set the way you want it to be, or you can use it to collect data for your focusing models. But writing scripts is actually kind of fun. It's neat to write something and then turn it loose and see the machine go do your bidding. And it gives you kind of an appreciation of everything that's involved and hidden behind the scenes. So this is a simplistic diagram. If you have these low-level functions here within SkyX, and then on top of them are functions that relate to things like guiding or finding or camera. And then you have a GUI that lets you control these functions. But if you're writing a script, you're kind of coming in on the side. You're backdooring the system. And you can come in with this Microsoft Windows interface, or you can come in through the JavaScript system. And this scripting calls can come in over TCP/IP, or they can come in, if you're using JavaScript, there's an environment that you can sit there and write your programs and submit them to the system. So essentially your programs come in here and they go right into the function level. Now, not everything that can be done in a GUI can be done through a script and vice versa, but a whole lot can. So I just talked about the IP system. Now, we normally think of that as a networking system, but it's also a way of passing data between programs on the same computer. So this is an OS X system. This is SkyX running. This is a script running in a terminal window, and it's passing network commands, it's passing commands through the TCP/IP interface, telling SkyX what to do. This is the exact same script as this. It just happens to be running on a Windows computer, and it's going over the network, and it's coming into this machine, and it's going ahead and telling SkyX what to do on the Macintosh. So that's an example of networking. Now, we wouldn't normally do this. Most of us would probably just run it all on the same machine and use TeamViewer or something like that to come in remotely and run your system. So doing it this way is really just kind of a party trick. But it's kind of fun to daydream about what you might do in your retirement if you won the lottery. So you could, for instance, have numerous mounts and telescopes all running on their own machines, and then you could write a single script somewhere that orchestrates all of these machines to work together. Or if you've got more humble aspirations, you could just use your iPad and you could run it through the network, which is exactly what Sky for iOS does. It runs a machine running SkyX Professional over the network for you. Now, we're going to dive into JavaScript because that's the programming system that exists on SkyX on both platforms. And a little bit about JavaScript. It was created by Netscape in 1995. It's a C family type of language. It was originally distributed as LiveScript, and it was meant to do things like pop-up windows on your web browser. Very lightweight stuff. And since then, it's grown a lot. It really has nothing in common with the Java language written by Sun Microsystems, but Java was very trendy in the 90s, and so Netscape decided to rename LiveScript as JavaScript. Now, meanwhile, Java is still around, but it didn't take on the world quite like it had people had imagined. But JavaScript has hung in there as a web browser scripting language, and it's also become kind of a de facto scripting language for all kinds of stuff. Now, JavaScript programs running on SkyX look and behave pretty much like JavaScript programs that run on a web browser or anything else, but the focus, to forgive the pun, is different. It's really about batch automation on SkyX. It's not about interactivity. So all the functions that you might be accustomed to in JavaScript, like the math library and string manipulations, those are all there for you to use in SkyX. But ironically, you can't put a pop-up window up. as far as I'm aware. And it's not really meant for that. It's sort of like submitting an old batch job on a mainframe, and then you'll get output at the end of the run. So it's kind of funny, and if you're used to working in an interpreted kind of interactive way, it's kind of an interesting way of working. SkyX scripting is also a product of evolution, and you'll see that. There's a lot of backwards compatibility for old software in here. Now, when you decide you're going to write JavaScript on SkyX, you've got an editor, and you've got a debugger, and you also have these simulated devices. So SkyX, like a lot of other programs, like say Sequence Generator Pro, can store profiles of hardware. So you can use it on different combinations of mounts and cameras and just call up the profile you want. Well, some of the devices that SkyX can support are actually fake. They're simulated mount. So you can slew this simulated mount around the sky, and it will behave just like you had a real mount hooked up to it. And you have a simulated camera that will take simulated pictures, which it gets from the Digitized Sky survey. And this is not real interesting if you're a normal user. But if you're a programmer, it's a godsend, because you don't have to waste your time plugging the software into real hardware at night to test your scripts. You can run it all on the simulator, or at least you can run most of it on the simulator. So this is a glimpse of the scripting environment. It's very primitive, but it will get the job done, and you can use it to submit things and edit things. It's nice if you have a real text editor to work with, and you can copy paste your source code into there. Now, we're going to dive into actual JavaScript code. And I apologize in advance, some of it's very small, so you may have to lean forward and get close to the monitor, or leave the room. Something about programming, though. Most programming languages have a syntax that enforces a particular style. And like I said, JavaScript is a C family language. And so if you're used to programming in C, or one of its derivations, you'll be at home with JavaScript. The problem is, I'm not really a C family programmer. I programmed in Modula 2 and Ada and even in Fortran. So I kind of have a different way of structuring things, so I hope that that is not going to be too distracting. I'm also a very verbose programmer, so I comment the heck out of my code, probably to the point of extreme. So these are some samples of actual SkyX commands through JavaScript. And if you look up here at the top box, you have three main types of things you can do. You can change settings in the program, like you are telling the CCDsoft camera module. Notice that's old school there. It's from the old software, but the name still is with us today. So you're telling the camera to set its exposure time to 5 seconds. And if you put that in the script editor and you click run, you'll notice that whatever exposure time you had has now become 5. And the next one issues a command to take an image. And then the next one's a little more complicated. I'm defining a variable called guider type, and I'm using a call called selected hardware auto guider camera model. And what this will do is it will just return what kind of a guide camera the system is set up to use right now. And if you look down below, you can see an example of how you can use that. So in my scripts, on my system, I have an STI, which, by God, has a mechanical shutter, right? But I have all these friends that have QHYs and load stars, and I got tired of maintaining 2 types of programs. So I could build a loop in here, and that it basically says, all right, if it reports back that there's an big STI connected to the auto guider, then I want you to set image reduction to 1, which is the command in SkyX for using an auto dark. So it'll go ahead and take an exposure with the shutter down, and then it'll take the real exposure for you. And then if you don't have that, it doesn't do that. So you don't, have to go put your hat in front of the telescope if you're, using something without a mechanical shutter. This is another very sort of simple linear program. And you'll see up at the top, there's a connection statement. Again, CCDsoft. And I'm telling it, connect to the filter wheel. Now, don't worry about the details. I just want you to get a gist of what you can do and what this kind of stuff looks like. And then what I'm doing is I'm doing the luminance filter. I'm telling it to switch filters to filter number 3, which for me is my luminance filter. And then I'm running the @focus command. Now, @focus, if you're not used to SkyX, is its built-in focusing system. And if you have it set up, it will slew off and find a guide star, focusing star. It will set the exposure, and then it will proceed to rack the focuser in and out while it takes pictures, and it will create a curve, and from that it'll calculate, the ideal focus. And then it will store that ideal focus in a model, which it can then use later for calculating offsets or thermal changes if you want to go that far. So what this does is it goes through and it collects basic data for my 4 wide band filters, and I can run this periodically if I want from the editor, and it will help me build up my offset data. Now, this is a very primitive example of how to conduct a slew in an image. So this is something kind of useful. If you wanted, say, to image Thuban, you can read through there, and I'm going to go very quickly through these variables because they're not that interesting. The asynchronous command essentially says, I want you to complete every task before you go on to the next one. So, for instance, you don't want it to go slewing to some other target while it's still taking an image. Now, there are some tasks that you might want to go off and do their own thing in the background, like guiding. You don't want guiding to, you don't want it to wait for the guider to finish because it's never going to finish because it's in a loop. Now, that autosave just says save the pictures that you take. Regulate temperature, it's a little late here, but it guarantees that your cooling is running. Image reduction, again, is the auto dark. Frame equals 1 tells it that this image is going to be a light frame. Now, that's important because when you save the image name, it's going to name it after the target, and it is going to perhaps name it dark, light, flat, bias, whatever kind of frame it is. I'm not doing a subframe. That delay is basically a settle. It means when you're done slewing and I've told you to take an image, I want you to wait 1 second before you actually execute that image. And then I want you to take a 1-second exposure. So that's what that one does. And then the next command, that slew to RA dec, just tells it, I want you to slew to RA 14, and notice this really bad decimal here, and to declination 64, and I want you to call that place Thuban. Now, you could call it anything you wanted. You could call it Fred or Myrtle, but that is what is used to name the file, so it would make sense. And then finally, you're telling it to take the image at the end. So this is just an example. And I took a long time with this example because we had all those variables up there. This is a little bit more sophisticated version. The variables are all the same, but if you notice here, what I'm doing is I'm telling it to find Thuban on the sky chart. Notice it says SkyX. This is another old school reference as well. And then the next thing I'm doing below that find is, remember, SkyX has huge databases of information about all these objects. So property number 54 in the database corresponds to target RA. Property 55 corresponds to declination. And so I'm pulling that information and I'm stuffing it into a variable called target RA and target dec. And then I'm using this SkyX RASCOM, here's another old school reference, to slew to the variables rather than the hard-coded RA and dec, and then take the image. So that's a little friendlier there. You can also, if you have multiple targets, instead of just having it slew to one thing, you can build an array. So an array is just a variable that stores several entries in it, and they're all indexed. So target 0, index 0 is Thuban, and then target index 1 is Edasich, and then Alteus. And then I have another array here, which are my exposures. So I'm going to say take 30 seconds at Thuban and 45 at the next one. And then I've got this counter variable down there, 0, starts with 0. And then I've created this while loop. And target.length is just the JavaScript command that says how many things are in this array? And in this case, there's 3 things in this array. So it'll go through and it'll find the first one, target 0, because remember counter 0. And it'll pull the right ascension, it'll pull the declination, it'll slew there, and it'll name it whatever the variable target 0 is, which you remember again is still Thuban. Now it goes to exposures and it pulls that first exposure variable, and that's what it sets for the exposure time. And then this counter plus plus is I'm just incrementing the counter, and it'll loop through and do 1, and then it'll loop through and do 2. And then at that point, I've reached the same length as the target length, and it'll quit. Now, if you get tired of all these properties and variables for right ascension and declination, you can use the closed loop slew command, which is, remember, the plate solve enabled slew. So what's going on is I'm telling it to find this target up here, target counter 1, which will be Thuban, and then I'm executing the closed loop slew. So that will slew to the target, take a picture, plate solve the target, or to plate solve the image, adjust the position to center the target, and then take a second picture to confirm. So in my system, I have it set that the exposure for the closed loop slew is about 10 seconds, and then it takes about 5 seconds to solve. It's a local database, so you don't need to be on the internet. And it takes 5 or so seconds, and then it takes a few seconds to adjust, and then it takes another image. So that's really a quick thing to program. You just throw closed loop slew.exec in there. It's marvelous. And it will be deadly accurate. The target will be total center of your field. But it takes about 25 or 30 seconds to execute it. So if you're going to run off and take a 5-minute exposure, no problem. But if you're trying to take quick exposures, that's a lot of overhead. So you have to think about the tool there. Now this is just another example that's built into an array. Instead of having 2 arrays, one for targets and one for exposures, I have 1 array, targ data. And I've got the target and I got the exposure, and the target and the exposure. And I just set it up in this sort of odd looking table form so that it would be very easy to go in here and add more, remove more, and you see what's what, and it's easy for the user to edit. And then the only real difference is that I'm saying go to the target 1, and then the exposure is stored in the next part of the array. So I'm using counter, which is 0 in the first run here, and then counter 0 plus 1 is 1, and so that comes up with the exposure. And then I have to increment it by 2 each time, if that makes sense. I should probably go up. No, that's correct. Yeah, because that's going to weigh in the total number of objects in the array. So that works out well. Now, I've been throwing a lot of commands at you. It's like, great, where am I going to find these? How am I going to figure this out? Well, like everything today, the documentation's online. And there's actually a link from the JavaScript environment to this URL at the top of the page. And if you go there, you will find that there are 3 sort of sets of objects that you can play with. There's the TheSkyX objects, which are TheSkyX application specific and new things. And then there's these classic objects, one for Sky6, and that relates to things like object information, running the telescope and the chart. And then the CCDsoft classic objects, which are manipulating the camera and analyzing images. But then new things like closed loop slew are up here with TheSkyX objects. So it's a little schizophrenic, but it does make sense. Now, when you dive into things like the CCDsoft example, I'm going to give you some examples of what you could find in the CCDsoft camera class. So these are anything that involves running your auto guider or your imaging camera. And Bisq likes to use weird terms that don't really mean anything to me, but if you're a programmer from another tradition, maybe they do. But these public types are things that provide information to you. So what I'm telling it is, if not, the CCD auto guider state is 0, then the camera's busy. So when I run this CCDsoft autoguider.state command, it brings me a number. And you can experiment with this in the JavaScript environment. You just type it in and punch run. And it'll say 0 or 1 or 4. And all those numbers mean something. but 0 means it's idle. So all I want to know is it idle? And if it's not idle, that exclamation point being a not, which is standard JavaScript, then you'll know it's busy. So then you also have the ability to run commands like take image and abort whatever's happening. And there's scads of these commands. And then there's properties, which is what I had mentioned before about setting settings within the program. So your exposure time, your autosave, your image reduction, in this case 0, which means don't do anything. Just download and save the image. So some hints for kind of navigating your way around here is I would tell you to peruse the online documentation. There's a lot there, and you just have to read through it and see what kind of stuff is available to you. And you can also use the search function from within the documentation. So if you're trying to, for instance, change a filter and you don't know what the command is, you can just type filter and it'll find for you the commands for filter. It actually works pretty well. There's also example code. Well, actually, let me skip something there. You can ask for help on the forum. Now, if you're a Bisq user and you hang out on the Bisq forum, you will know that you're going to have to provide a lot of specific information. They're going to want to know what operating system and what kind of computer and what did you do to do it and what happened and what did you do to ameliorate it, and you're just going to have to flood them with that data. They're engineers. They really like the data. So if you ask specific questions, you can get help. There's a lot of examples of scripting. You can find examples within the forum. So just do a search within the forum and you'll find all kinds of things people have written. There's a guy named Terry Friedrichsen who's written some great tutorials. He's got 3 of them. And that's how I got my start. Last I checked, his site was offline. But Terry's a real man. He doesn't run his server in the cloud. He runs his server in his observatory. And his observatory is out in the desert. And so sometimes the server may not be up, but give it a try. It's a great place to run through his tutorials. You can also find Visual Basic examples, which may not relate directly to JavaScript in terms of the syntax of the language, but the commands for TheSkyX are identical. So if you see somebody doing something with a sky chart in Visual Basic, you can steal that and do it in JavaScript. And then there's lots of JavaScript examples out there. But like everything, start small, work up, use the simulator, but remember it's not real equipment. You should also get yourself a real text editor. And what I mean by that is something that doesn't, for instance, change your quotes to smart quotes and stuff like that. Just be patient with yourself because bugs are going to happen. In fact, TheSkyX has bugs, and you might find them. Try to avoid the tunnel vision. You'll get very locked into solving a problem in a particular way. And then just remember, you are probably not writing a script for the world. You're writing it to be a tool for yourself. So you kind of have to write something that'll work for you and just be happy with that. But in the end, cursing is therapeutic, and you will create monsters. So you might create something that looks great, and then you'll kind of come back later and see what it did, and you will be surprised that it did not what you wanted. So at this point, Adam, are there any questions? Or
Well, the first question was answered just as it was asked. Does Bisq provide a reference guide with these commands? And it was just as you came to that slide. I have a few questions. Is this the end of your presentation?
No, I was actually going to step us through an example of something, if you're willing to hang in there with me.
Let me ask one question because it's pertinent to just a couple slides ago. Basically, when you're writing scripts for the camera, to call something from the camera or auto guiding, the camera add-on would be required in that case, correct?
I'm sorry, what, Adam?
You would the camera add-on would be required for that?
Absolutely, yeah. You do need the camera add-on in order to work with the camera.
Okay. So that's what adds that functionality to be
correct. Yeah.
Okay. All right, and the other questions I'll wait till the end.
Okay. So here's a bigger example. Now I'm an OS X guy, and if I were running Windows, I would have bought something. I would have bought Sequence Generator Pro. I would have bought something that would have worked for me. But I thought, I'm a masochist, and I wonder if I can do some image automation on OS X, because there is no automation program for OS X. I would have to kind of write it myself. So I thought I would play around with it. And I didn't want to write it in the JavaScript environment because I needed to be able to interact with it. I needed it to tell me what was going on real time. And I didn't want to have to edit the source code every time I changed a target. So what this meant was I had to write an external program, which for me was going to be just a shell script, which is an interpreted Unix language. It's sort of the Unix equivalent of a batch file, if you ever wrote those for DOS. And the Unix script would then do the thinking and the reporting, but it would control SkyX by sending little JavaScript commands over to it. So that was my architecture. And that's actually very much the way real automation programs are written for SkyX. They are written in C or Visual Basic, and they send a remote procedure call. It's just that in my case, I don't have a direct remote procedure call system. I have to send a script to do my bidding for me. So this might clear up in a minute. But what I wanted to do was to be able to slew to the target, find a guide star, and start guiding. I didn't have to worry about calibration because SkyX is good about saving those settings for me. In fact, it encourages me to be very lazy. I probably haven't calibrated my guide camera in about 4 months, so I should probably do that. The guide star acquisition, now that's a rough thing that you have to do. I needed it to be able to handle filters, and I needed it to be able to do offsets between the filters. And if I hit the meridian, I wanted to flip it. If the target got low, I wanted it to stop. I didn't want to have it keep imaging in the light. There's nothing more pathetic than waking up in the morning and walking out to your mount and find that it's still taking pictures, even though the rosy fingertips of dawn have been caressing it for hours. I wanted it to refocus if the temperature changes. I wanted it to dither, and I wanted it to be able to handle things like clouds, if possible. And then I also wanted it to stop, because you remember my Takahashi doesn't have a stop. So I need to make sure that it stops. So what I did is I created a bunch of JavaScripts. And I started off at the top with this bash script that does all of the thinking. And then I created JavaScripts that were very function-oriented. So I've got one that checks the auto-guider quality. I've got one that does closed-loop slews. I've got one that invokes @focus2. All kinds of stuff here. You can see what they are. And then at the bottom is TSX Feeder. TSX Feeder is a great program written by Terry Friedrichsen, the same guy that did the JavaScript tutorials. And he's an OS X user. And TSX Feeder will allow you to take one of these JavaScript files from the command line and send it over the TCP/IP port to SkyX. And it will do it very elegantly. It will strip out comments to make it smaller, and it will let you substitute variables. So for instance, the CLS script up there, the third from the top, I have a variable in there for the target, and TSX Feeder will substitute that out and send the script on to do my work for me. So run target uses TSX Feeder to send all these JavaScripts. So it looks complicated, and it is kind of hairy, but I'm surprised. It does generally work. So here's a sample run. All right, so obviously I just did this to collect some data. I got a couple of these runs, so be patient with me. One is, why would I ever image Altair for 300 seconds? You wouldn't, but this is just a script. So what I type up here at the top is I actually type run target Altair 3x300. And I'm telling it I want it to take 300-second exposures through my red filter, my green filter, and my blue filter. Now, yours may be different. It doesn't care. These are just filter slots 1, 2, and 3. And I can put up to 8 filters on here. So there's a lot of combinations. So what it does is it starts, it runs the closed loop slew here, and that puts it dead on. Now, my Takahashi is a primitive go-to system, right? 1-star alignment. So I'm not going to waste this closed-loop slew. I'm going to go ahead and resync that. for my purposes. It analyzed took a guide star image. It found a guide star candidate at this coordinate here. It decided that it settled down and it looks good. It settles for an additional 20 seconds. Now it just gives me a summary of what it's going to do through the filters, 9 exposures for 45 minutes, and it grabs the temperature here of the focuser. And then the next thing it does is it starts imaging. So it starts 1, 2, 3, and it goes through the first 3 filters. Now the next images are going to be redos. I'm going to come back to red and back to green and blue. So I want to do some dithering before I come back. But the other thing it does is it checks the guide quality, and it says, okay, the guider seems to be in the right neighborhood. Now that's not an absolute sub-pixel quality. That's like 1.5 guider pixels. It's within 1.5 guider pixels. And the real purpose of that is in case an airplane flew through the field and now the guider is chasing it across the sky, or a cloud has shown up and it's totally lost where it is. That's what that's meant to find. And in each case, it's tracking okay. So the next thing it does is it says, all right, it's not dropped 1 Celsius in degree. We're not going to worry about it, but it's going to dither. And it says the old guide star was here. And it uses a very primitive dithering system. It's a random number generator. It creates a number from -5 to 5, and it adds that to the existing X and Y values as an offset. And then it moves the guide star, and it waits for it to settle, and it makes sure it's in good shape, and it starts on the run here. And it tracks and reads out through, you know, it crosses the meridian. It's down across the meridian. So crossing the meridian means it's going to stop. It's going to close the loop back to the air. But since it's on the meridian, the mouse will flip. And then it's going to go ahead and start imaging here. And that's fine. And now actually, let me step back here. Notice this guide star is at a Y value of 4. That's lousy. My script would actually never choose a guide star that lousy. It would never pick anything close to the edge like that. What that means is that my script read through the image, analyzed all the stars, and it couldn't find anything that it liked. So it basically threw up its hands and it said, all right, screw it. There's this bright thing here, and I'm just going to guide on that. Now, I know it won't be a dark pixel because I have a mechanical shutter, but that's not an ideal thing. I could, for instance, dither that off the side of the chip. But it tracked and it did just fine. But at the end of image 8, the guider got lost. It's because the cloud that got in the way of the stars up here is thicker now. And I know it was a cloud because I stepped outside and I looked up and I saw that there was a cloud. So what it does is it doesn't know what's going on. It turns off the guider. It cycles the connection in case there's a hardware issue. It waits 5 minutes, and then it tries to find itself again with a closed loop slew, which it succeeds in doing. Finds another guide star. Notice it's the same lousy guide star. And it has a lot of trouble getting that thing to settle because the seeing is really terrible. But it goes ahead and it slogs through and it finishes the last image, number 9 of 9, and then it turns off the guiding and it parks. And I can declare that victory is mine because it worked. Now it had a little trouble, but it worked. You still with me, Adam?
Yes, I am.
Okay, so this was going to be the end of the presentation, but sometimes when things don't go right, it's more interesting than when things do go right. So after this, I went ahead and I wanted to collect some data. I wanted to show you guys that it could actually work, right? So I decided to fire up, you know, NGC 7331. And sometimes you'll come out in the morning and you look at your script and it did something wrong. So you got to play the post-mortem game of look at the logs and look at the images and figure out what happened. So I went ahead and I kicked off NGC 7331 and I told it that I wanted to do 25-minute images through red, green, and blue each. And it started and it went marching off and I took a shower and I went to bed. And it did 30 images and a meridian flip and 8 dithers and 3 automatic focuses when the temperature changed. And when it was coming back from one of these temperature change focuses, the closed loop slew failed. Well, the script says, geez, it failed. I don't know what to do. So it went ahead and parked the mount at 2:13 in the morning. Now, I'm a man of a certain age, and so I get up at night because, you know, I got stuff to do. And when I was done with the bathroom, I peeked out the window and I saw that my mount was parked. And I knew something was wrong because it shouldn't have been parked yet. So I went out there and I fired it back up, and there were some clouds in the sky, and it went ahead. I told it to do 15 images, and it did the first ones. And then for the number 3, the guider appears lost. And so it went and tried to figure out what was going on, and it cycled the connection, and it waited 5 minutes for the clouds to clear, and it did a closed loop slew back to the target, which succeeded. And then it tried to snap an image with the guide camera to analyze it and find a guide star, and it failed. And it says, I don't know what to do. I think I'm clouded in, and it parked for the night. So I was already in bed asleep again by this point, and it had a glorious 20-minute run. Not quite what I had hoped, but the post-mortem for this was that at 3:43, it took an image with the guider, and it chose that star. That's what it guided on, and it was successful with that. This is the red image. It took a 5-minute exposure, so you'll see the galaxy dead center, but you also see these nice wavy, cloudy things going on here. Useless as an image for photography, but the mount doesn't know that, the script doesn't know that. So then 5 minutes after this, it comes down with the green image. All right, this is looking pretty rough. But you can still see the stars through here, right? So that guide camera doesn't know any better. It's still humping and guiding, and it's happy until the blue comes along. Now, there's some really bright stars that made it through, but remember, this is a Sony sensor exposing for 5 minutes, whereas my guider is a much less sensitive Kodak, and it's guiding for, or it's imaging or exposing for 5 seconds. So it's 1/60th. So it lost the guide star. This is what happened. So when it tried to re-find itself at 4:04 a.m., this is what it saw. This is the analysis frame used by closed loop slew. And you can see some stars in here. This was enough. SkyX saw those stars and calculated where it was. The plate solve was successful. But in the next few seconds, remember, while it's thinking, it's then going to take a confirmatory exposure. And this is what it was. This was 15 seconds later, and there's nothing there. This is 10 seconds, a 10-second exposure. So, of course, the script didn't know that. This picture is just there for you to look at. So the guide camera tried to take an image, tried to get a star, and this is what it saw, which was nothing, and caused the script to halt. So I did collect data, though, and I wanted to throw up to remind you that I just did this as a quick and dirty process, so please don't judge it on its artistic merits. It did collect 30 images in its run. Of those, I had a wide range. The median FWHM here was 2.8, which on my camera, I've got 1.1 arc seconds per pixel imaging scale on the image. I wound up choosing, basically the better half. So I got 16 images. This is what I got. I dusted off my 3-month-old flat and dark masters because I really haven't done any imaging in a long time. I did a really crude median combine because it was very noisy data. And then my processing was nothing more than an ABE. And then I did an STF, and then I did a quick denoise. And this is the crop of the galaxy with some beautiful satellite trails still running across it. So this is a truly bad image. But it did collect the data, and there it is. So victory's mine. The script did not fail. And when you come out in the morning, you kind of have mixed feelings. It's like, gosh, my data sucks, but the script ran. So if you're curious about the script and how it works, or you own a Macintosh and want to try it, you can go to the Bisq forums and you can download the latest release. Just basically go to the forums and search the forums, not the whole site, for OSX script, and it will bring up the thread, and the script package is attached to the thread. And if for some reason you really like command lines or you're really thrifty, you can run this script on Windows, but you have to have the Cygwin Bash environment. And if you want, drop me a note and I can tell you how to do that. But you know, you probably would be happier with a third-party product from a real company with real support. So on that note, there's a number of people that helped me out, and I would like to acknowledge their assistance with ideas, code, examples, and testing. There are actually people who wasted perfectly good nights testing my scripts, and I find that an amazingly generous thing to do. And then I'd also like to thank everyone at the AIC for helping me with the presentation and giving me a forum to talk. So on that note, I am done, and I'll see if I can bring this back. Is there anybody left?
Yeah, there's actually still a bunch of people in the room. So anyone out there in the room, ask your questions away. This is people on the YouTube side, same for the people in the live room. I have, first of all, a few questions. The error controller, specifically the image output that you got, the guider frame, did you have to program those into the script, or is that something default in the Sky?
I did. Well, sort of. It's a combination. Let me flip over to the desktop for a second, and I'll show you what I did. If I can hit the right button. Basically, there are functions. There's a function in the SkyX which you can call, and it will. Let's see here. It's over on my server, so I have to dig it out. And you can call that, and it will report to you the error rate. But then you have to do something useful with it. So, for instance, when I check the AutoGuide quality here to make sure that the star is settled, what I've basically done is, I don't know if you can see this, it's very small,
yep.
But I'm running this command ccd soft autoguider guide error x, and this returns the error in x. And I'm using the JavaScript math function, and I'm using ABS because I don't care whether it's positive or negative. I just need a number. And I'm asking if it's less than 0.6. So if the error for x and y are both less than 0.6, which remember these are guider pixels, so they're kind of big, I'm going to set this variable quality as good. And if not, I'm going to set the variable as poor. So like most things here, it's kind of a combination. Did that answer your question, Adam?
Yeah, for the most part. But like, so then to get the, I'm assuming when you wake up in the morning, you've got that final guide frame in a directory somewhere, right? So it was cloudy or.
Yeah, what happens is I do save every image that my imager takes. So what SkyX does is if it's a bona fide image that I'm taking of the target, then it will get saved out to a directory that I specify and named according to what I call it, what I want to call it. If it's something that's used for closed loop slew, or if it's used for focusing, SkyX saves those as well, but it puts it into a different directory. So they're not all commingled, they're kind of organized. Now for the guider, I do not save the guide images because I would have one every 5 seconds. But whenever I run a procedure that analyzes the guide image for some reason, like it's looking for light sources, it's trying to find a guide star, I have to save that. So the script will actually say, save this one, it runs the analysis, and then it turns the saving off so I don't fill up my hard drive.
Gotcha.
And so in the morning, I have a real mixed bag. If it was something taken with the imager, I have it. If it was taken to a guide star, I may not have it.
Yeah, that's really cool. I mean, I'm just thinking about the ways I've troubleshot things that have gone wrong, and sometimes you don't know exactly what went wrong, but that really gives you a lot more evidence.
Yeah, you may not always find the smoking gun. I mean, I found one actually. The first run I did on Altair, one of the closed loop slews failed. which is extremely rare. It's normally very reliable, and it failed. And so I went and I found the file because it had saved it. It was an analysis image. It was in the closed loop slew folder, and it had trails. And what had happened for some reason is it snapped the image before the mouse stopped moving. And I've never seen it do that, ever. I have no idea why it did it. It did it that time. It's never done it again. But I did add a delay in the script. I now told it, wait, 3 seconds before you take that image. So I don't know if it'll work. It's, some days you just try it, you throw things at it and see what sticks.
Yep. I see a question from Larry. Once you have the script for a night's imaging run, could you explain again how to send it to TSX? And when the script is running, can you monitor it somehow?
Yeah, so what happens is when I open up a terminal window and I type the name of the command, so I type run target, the name of the command, and I give it the target I want to image, and I give it the parameters I want for the exposures, and then it proceeds to just dump it out to the terminal screen. So those captures that I showed you of the log, it doesn't really log it. I just scrolled up in the terminal window and selected them all, and I copied and pasted it, put it to PowerPoint. Now what happens is the script will run in its terminal window, and there is actually, inside of the script, it fires up TSX feeder, and TSX feeder has several parameters, and one of them is the name of the script, and the JavaScript, and it will then use it to feed that script across the port. So I can show it to you if you want. Otherwise, you can download the script itself and actually see how it works. If you guys, get your website up, I'll be happy to upload this stuff up there too if you want to post it.
That'd be great. Yeah, it might be for a mini vid or something like that. It might be.
I don't know if that answered the question. If it didn't, let me know and I can try to explain it better.
Well, I think you're executing commands.
Yeah, so the script basically is like an old batch file. You're just, giving it different commands, and TSX feeder happens to be one of those commands. And when it comes time to say, get the focuser temperature, it just says TSX feeder space, and then the path to the JavaScript command that asks SkyX for the focuser temperature, and it runs the command, feeds it to SkyX. SkyX answers with the number that comes back, and then TSX feeder provides that to the bash script. And then I will often take the output and do something with it because it may not come in a format that I want. So as a simple example, Bash's scripting environment is a system language. It's not really meant for anything scientific, so it doesn't know how to do floating point numbers. So when you get a focusing temperature back, and it might be, say, 21.2, well, I want it to do something if 21.2 is less, is a certain value compared to something else. But since the script won't handle floating point, I have to use another program and multiply it and turn it into 221. And so there's weird stuff that you have to do because it's a limitation. If I were using a real language, I wouldn't be hamstrung like that. Mm-hmm. But of course, if it was a real language, it wouldn't be interpreted. You couldn't just download it and pick it apart and change it.
Mm-hmm. All right. The fact that it operates over TCP/IP is interesting too. Versatile. I mean, you basically then just have to be on the network to run it.
Correct. I mean, you would have to have your gateway set up to allow, incoming IP on a particular socket, number and things like that. But yeah, you could do it. I mean, like I said, most of us would never do that because it takes a certain leap of faith to run the script on a machine and then not have any feedback, being able to watch the guide star or watch it while it's working. So most of us would just use, screen sharing or team viewer. I mean, that's what I do. The machine sits in the backyard, and I just connect to it over my Wi-Fi network.
Mm-hmm. Any limitation to the number of the objects in the array? Probably not.
I suspect that it's some increment of 8, but I don't know. For example, the biggest array I've ever worked with in JavaScript is some of the light source arrays. When you want to analyze a guide image, say to find a star, there's a procedure that's built into SkyX that goes through and it analyzes, it grabs everything that it considers to be a light source in the image according to a formula, and it calculates its brightness and its coordinates and its size and all that kind of stuff. And those arrays can be hundreds of objects long because you can have lots of stuff in there. But I don't know whether it's a 32-bit number or a 16-bit number. I have no idea.
Okay. I know there are some, sequence generator has a limit to the number of objects, and if you want to do stuff like supernova hunting or that type of thing, you are going to rely on something like the Sky.
I'm sure that you could probably put a couple. I mean, I'm sure you could put 256, maybe more, objects into an array like that. Now, of course, if you wanted to say use my script to image multiple things in a night, what you would do is, because it's command line, you would write a second script, and that script would just run my script multiple times, one after the other after the other.
Right.
And if you really wanted to do that, you would probably hack my script to keep it from parking the mount, after every single run, because if you're running multiple objects, that would be kind of wasteful to do that.
I was actually thinking maybe like running an array generator, or like
you could do that too. You could write a program that would create a program, and then you could run that. I've thought about that. You could write something that would, say, pull certain objects from the database and then sort them according to their location across the sky, at night, so you could optimize that, and then you could use that to feed into something else. So yeah, there's all kinds of stuff you could glue together if you're diabolical enough.
I know the guys on the outside are on a delay, and I think Larry just did it again and asked this. Well, kind of made a comment, the same exact comment I made at the same time. I have a great idea. How hard would it be for you to write a program that would write the scripts for you? You would have a template where you input the target, the required images, the targets. That would be, so kind of similar, yeah.
Yeah. So you could certainly do something like that. Now, again, with this program, the answer is, of course, not how hard it would be for me to do it, because I'm never going to do that. It would be how hard it would be for you to do it, because now you know how to do it. So, my goal here was to sort of create a 2080 solution and a tool for me to use. And if other people could learn from it or use it, I think that's great. But people would come to me and they would have all kinds of great ideas, and I'd say, that's great, and I would take their idea and I would put it in the program, and other people would have ideas that would be great ideas too, but I was just too lazy to do that.
Yeah. Maybe your mind would change if someone was paying you to do it, but...
Yeah, but that's why I'm an emergency manager.
Yeah.
To ask a question about that, the idea of having a program that writes scripts for you. What does CCD Commander and CCD Autopilot do?
They're written, and I don't own either product, but it's my understanding that they are written in a high-level language like C or Visual Basic, and they make direct procedure calls into the SkyX. So with SkyX, you can send it a direct call from your compiled language that says run this. Or what I'm doing is the alternate. I'm using the JavaScript connection. And again, you have to be running on Windows for that COM interface to work.
Yeah, I know Brian Odom had a few questions, but he left the room. I don't know if he got locked out, but he did the marathons.
I frightened them away.
Yeah. He did the Messier Marathon, and I don't think he used a script. I think it was all manual. But
yeah, as I recall from watching that episode, that was serious coordination and human ingenuity to get that to work.
Yep. Yeah, I think once they put that into a script, everyone's going to be doing it. So, or trying it at least. But then more people will be successful.
Right, and if you wanted to do something really quick, you could take that example I put of the array and just put in, you could put your Messier objects and it would go. But notice that, like I said, that doesn't do any guiding. So if you're running some high-end mount and you don't need to guide, then great. Otherwise, it's fine for supernova searches and stuff where you might need a few seconds of an exposure. But when you're guiding, that really throws, a monkey wrench into it.
Yeah. Yeah, one more big thing that can go wrong. We have never had a good demonstration of the Takahashi mount as well, so thank you for that. That was really cool, and I think that the polar scope has always been something that they really nailed, and I was glad you elaborated on that.
Well, and it was nice to see your presentation on the AP polar scope. It's funny, people. I don't know. I mean, my system is very forgiving because I have low focal length refractors, but that polar alignment scope is very fast, just like it would be on an AP. It's a nice way of doing it. Unfortunately, it drops out because it costs money. I mean, I know every design is a compromise, but I found it very ironic that the MIT, which is the first Paramount that they've really pushed as being a portable one, is really the first Paramount that there's no polar alignment scope option for. Now, I know that you can set it up and you can run it, and it has very sophisticated alignment procedures, but I'm old-fashioned. I'm old. I like polar alignment scopes.
I'll chime in on that as well. I am very seriously, I'm just about to buy the Avalon M0, but to me, by far the biggest deal breaker on the Avalon M0 is that they've got a polar scope, but it's not set up in a way that there's any kind of software polar alignment routine that you can use. So the polar scope can only give you a very general polar alignment. You can't get anything accurate enough. And I'll go on and on about the EQ mod polar alignment routine is awesome. I mean, you can be under 1 minute within 60 seconds. It's like a completely forgotten thing, and I never have to even think about it, and I'm always super accurate. So
yeah.
I think it's designed the same way the TALK one is, too. It's just spot
on. One more question. Can you mix and match object types in the same script, i.e. CCD soft, SkyX, SkyX, SkyX? If so,
sure.
Yeah.
Yeah, I mean, and you saw that in one of the scripts that I did, for instance, all those scripts examples where I slewed an object, it used a SkyX classic object to select the object on the chart, and then it used a SkyX object to slew, and then a CCD soft object to take the image. They're all running out of the same program. They're just different ways of identifying the commands. They're all available for you to mix and match anytime you want within SkyX. Now, if you're running, SkyX, then that has other, commands. It's got the SkyX set. You can't bring SkyX commands into SkyX. It's not fully, it's not compatible. New scripts won't always run on old ones, but the old stuff will run on the new ones. I don't know if that makes sense.
There was just a question and it dropped off my screen. You mentioned using simulators for testing this stuff. Did you mention that you used TSX star database add-on to allow simulated closed-loop slews and guide stars? So
yeah, there is a something you have to download for closed-loop slews to work. You don't need, within SkyX they have a really I don't want to call it complicated, but a high-end database. SkyX comes with databases and star catalogs and things like that. If you want to use the closed-loop slew function and you want to use the blind, solving functions, you need to download a database from the from the BISC website. It's about 2 gigabytes, as I recall, and so it's a big thing. It comes compressed and it uncompresses to that size, and that doesn't cost any extra money. You don't need the database manager. That's the extra $1, extra cost database manager. If you really want to, if you say you had a really big telescope and it could resolve tiny stars, you can buy catalogs that go beyond what comes in the standard product, and they actually are huge, and they come on an external hard drive, and that all costs more money. But for the closed-loop slew capability, as long as you have the camera add-on and you go download the database file that you can find from the download section, that's what you need. So that's a good point. It won't closed-loop slew out of the box. You've got to get that database down, at least for blind. There's two ways of doing closed-loop slews. One is the all-sky, where it does not care what the orientation is or where in the sky it is or what the image scale is. There's another form that you have to help it. You tell it the image scale, you tell it the orientation of, are you reverse image, are you not reverse image, and you have to kind of give it a rough estimate of where you are in the sky. That's the traditional image link, and it works very well, and it's faster than what they call the all-sky image link. I use the all-sky just because I'm lazy, and it works fine for my purposes. But if I were, for instance, using T-point, where I had to take hundreds of pictures and plate solve them all to figure out where the mount is pointing, I would set up the traditional image link. So I don't know if that answers that question or not.
Yeah, I think it does. That's basically the case with any plate solving software. You're going to need to download the database.
Yeah.
I mean, yeah. Off topic from Larry Groom. Living in Denver, have you ever visited the Bisque Boys in Golden? And I don't know specifically who that's for because you have a TAC, but I don't know. Have you ever visited Golden?
Yeah, I have visited Golden, and I've actually not visited the I have not visited the software Bisque company. At one point, I had a problem with my SkyX. It was loading very, very slowly, and I put in a comment in the forums, and I was getting help, and I said, "Hey guys, I could drive over there with it," you know, and they were really very eager for me not to drive over there with it. So I don't know if it's Skunk Works or not. No, I've never been over there actually, but they are right across town. Oddly enough, you know, if I ever do buy a Paramount, I'll probably wind up having to order it from somewhere. I don't know, you know, if it's better to pay taxes or pay shipping some days.
Yeah. Tolga's just commenting, when you own a Paramount, you need to let go of your old habits. That came in before this very recent discussion.
I know. I've been told that a lot.
I don't know. Whenever you buy any mount, the hand controller philosophy or just the mount philosophy is going to change what you do with it.
I mean, I suspect, you know, I actually have thoughts that I will at some point buy a MIT, because I've been soldering on with my Takahashi now for 12 years, and it still runs great. But if I had a MIT, I would set it up on a pier in the backyard, and I wouldn't be taking it down and setting it up. So, yeah, I probably, you know, you have to embrace the technology that the mount has.
Yeah. And I'm not sure of the price point of the tax, but the MIT is priced really well for its capacity. I think it's probably below the TAC prices.
Yes, and I was going to say that the tax are expensive, but if you have a chance to buy one used, they're quite good mounts.
Yes. A good mount to buy on the used market, unlike the APs. They're good mounts to buy, but they don't lose any of their value, so you don't do much well by.
When I bought my Takahashi, the Mach 1 had just been announced, and I really wanted a Mach 1. And if it had been available, I would have probably bought one. And I've used, I mean, you have one. A friend of mine here has one, and it's just an awesome mount. But I had actually owned my Takahashi at that point for 2 years before they started shipping. So at the time, the Mach 1 and the Takahashi were about the same price. But what's happened over time is they've both gotten more expensive, but it seems like the Takahashi's gotten more expensive.
Yep. Yep, definitely. And let me go through. I don't see any new questions. Anyone in the room here have any questions for Ken? Oh, I see Brian Odom had some comments. Oh, SkyX camera add-on still does not control DSLRs.
It does if you have Canons. It may not control all Canons, but I know that it controls some Canons. There's a number of people I'm working with actually with the script that use Canons. I don't know the model names because I'm not a DSLR guy. I mean, I have one, but I use it for taking pictures of birds and mountains and stuff.
All right. Yeah, I don't see any other questions on there. I do want to remind everyone, Jerry Lodrigas Q&A next week. He's going to be on. You can ask him your questions and he'll answer them.
And he's a DSLR guy.
He's the DSLR guy. He's the one to ask the DSLR and a Canon guy. So, and he's been doing this longer than I've been doing it, longer than I think just about anybody has been doing it with a DSLR. He's really, I don't know,
Yeah.
I learned a ton from him.
Yeah.
But thank you, Ken, for coming on. This was a great presentation.
Sure. My pleasure, and thank you for your patience. I really appreciate it. And drop me a note on cloudy nights or something if you've got any questions about it. I'll see what I can do to answer it.
Yeah, and as always, I'll give Cloudy Nights a shout out. Ken's a moderator on there. Beginning and intermediate imaging, you'll find pretty much all of us. So that's where we are. Thanks again for coming. I don't see any other questions out there, so I am gonna stop the session. We didn't go too far over tonight, but thanks again, guys. See you next week.